Right, we will start the session. Yes, so we will start the session. This is the first question. I have already displayed you the question. It is a very good question from buoyancy. Okay, it's one of the, what is that? One of the good questions from buoyancy. Those who are there in the live, yeah, okay. So try to solve it. So we will solve it anyways. Okay, I will start solving it. Right. So to start this particular question, just a moment. Okay, right. So let us begin reading the question. A bowl is inverted symmetrically and held in a dense fluid, which is having a specific gravity of 15.6. So this is the dense fluid and which is having its specific gravity 15.6. To a depth of 200 mm, actually it is not visible properly, but they have given in the statement 200 mm measured along the center line of the bowl from the bowl rim. Okay, right. The bowl height is 80 mm. So height of the bowl is given as 80 mm. That is also, okay, here you could see. Okay, height of the bowl is 80 mm. And fluid rises 20 mm inside the bowl. So the fluid is not rising completely inside, it is rising only 20 mm. See, most of you would have seen it. Okay, so you would have done it. In fact, when you are, what is that? When you are suppose if you are taking bath. Okay, so mostly you will take that bowl and you will reverse the bowl inside, and you will able to observe that the water will not reach the top point, right? The water will reach only to some point. The balance part, okay, the balance part of the water, like if suppose if this is my bowl, it will reach only to some point. The balance part of the water will be filled with, that is, the balance part of the bowl will be filled with air. The same thing is happening here. This white color part is the air, and only 20 mm depth it is filled with water. Okay. So now the bowl is 100 mm. Okay, the bowl inside diameter is 100 mm and it is made up of old clay recipe. So this material they given, and the material specific gravity is given. So initially specific gravity of the fluid is also given. Now the specific gravity of the material, that is a bowl, is also given. Okay. So the volume of the bowl, so already the volume of the bowl is clearly mentioned in the question itself, which is 0.9 liter. So volume means what? It's a bowl, right? So volume of this thing. Okay. So if you consider something like this volume of this bowl, okay, volume of this bowl is given as 0.9 liters. Okay. See, you need to understand the difference. This volume is not stating the volume of the air or volume of the, what is that, liquid inside. It is just stating the volume. See, if you see the 3-dimension figure, this will be having a volume, right? Here it is, what is that? It's just a 2-dimension, but this thickness, the thickness of this particular bowl is going to have some volume, and that volume they given it as 0.9 liter. You need to understand the difference. See, let me just say it again. Suppose if this is the thing, I will be filling some liquid here. Okay, I'm filling some liquid here. Liquid here. This liquid which is filled inside will be having some volume, and this material, that is this material, this hollow cylinder. Again, we can say that the hollow cylinder is having some volume, and that volume is 0.9 liter. Okay, I hope you got the point. Now let us come back. The force required to hold the bowl in the place. So what they are asking, very simple. I'm just keeping that bowl inside. And what should be the force I need to apply? Okay, what should be the force I need to apply in order to maintain the bowl in this position itself? Now it is same what you did. What is that? What you did in, like, most of you guys would have done. Okay, so when you are bathing, you will take the bowl and then you will reverse the bowl and then you will insert inside the bathing tub, right? And when you do that, you need to apply some force. You will be keeping your hand here, and with the help of that hand you will be applying some force on this bowl in order to keep that bowl at that position itself. So that force, how much is that force? That is what I need to find out. Okay, that is what I need to find out. Okay, so first of all we need to understand what are all the different forces which is acting in this. Okay, what are all the different forces which is acting in this? First one is I need to apply the force. This is the force. Other than that, there is going to be buoyancy force, right? Obviously there's going to be buoyancy force. I will just take it as FB. and weight of this, what is that? Weight of this bowl, okay, that will be acting down. Was there any other force other than the force which I applied and weight of the bowl and the buoyancy force? Was there any other force? Okay, only one guy was there, right? So there is no other force, obviously. Buoyancy force, weight, and the force which I'm applying. Only these are the three forces which is present. So simply I can use summation of Fy equal to 0. And if I use this, I can state that Fb, which is acting up, minus weight, which is acting down, weight of the bowl, and minus the force which I applied, which is acting down, which is equal to 0. So if F is equal to, it's simply going to be, I will bring that W also that side. It is W minus, sorry, not W, FB minus W, FB minus W. Okay. So this is what I need to find out. So now for finding out this, I need FB and also I need W. Okay. So first we'll focus on FB. So what it is going to be, how this FB is going to be. So FB is simply like buoyancy force is simply the weight of the fluid which is getting displaced, right? So here, if I want to find out the weight of the fluid which is displaced, rho g of the fluid multiplied by volume which is displaced, right? Volume of the fluid which is displaced. Now here comes an interesting point to note. Density rho g of the fluid we can find out because specific gravity is there. If I know specific gravity, nothing, it's a nothing one actually. They given us the specific gravity. So if I want to find out the density of the fluid, simply multiply density of water into specific gravity of the fluid. This is a basic one, right? So density of water is 1000, and if I multiply with 15.6, it will give me density of the fluid. So no problem with density of the fluid and also with the acceleration due to gravity. But what is going to be the problem with volume of the fluid displaced? See, volume of the fluid displaced is nothing but volume submerged, right? Now, what are all the volume which is getting submerged inside? Yes, of course, this entire volume of the object, okay, volume of the body got submerged inside. Okay, volume of the body got submerged inside. In addition to this volume of the body, what is the other thing which has got submerged? Volume of the body, we already know. What is that? 0.9 liter, we already know. In addition to this volume of this, what is that? That bowl, in addition to volume of bowl, one more thing also submerged. What is that? Air, exactly. This air is also submerged, right? So rho, it is like, sorry, rho g of the fluid, which we know, and volume of the fluid displaced, which is nothing but volume of the submerged body, is nothing but volume of the bowl plus volume of the air. Okay, so we need to consider both. Volume of the bowl is 0.9 liter. I can convert it into meter cube 10 to the power of -3, right? That is 100 liters, sorry, 1000 liter. 1000 liter is equal to 1 meter cube. So 1 liter will be 10 to the power of -3. So 0.9 into 10 to the power of -3, doesn't matter. Coming to volume of the air. Okay, so volume of the bowl, we already know. I will just write down somewhere so that I can use it. I will write down here. Okay, volume of the bowl. That is given to us 0.9 into 10 power -3 meter cube. And now what is volume of the air? How to find out volume of air? So how can I determine the volume of the air? So I will highlight it. Okay, let me highlight it, not an issue. Right. Volume of air in the sense, yeah, we know the dimensions. That's what I was asking. So we need to find out that is exactly what I'm asking. We know the dimension. So we need to find out volume of the air, which is nothing but this part, right? It's nothing but this part. We already know that the internal diameter is 100 mm, which is given to us. And we know height of the bowl is 80 mm and depth of the water is 20 mm. So this height, okay, this height is going to be 60 mm. It's nothing, simple, right? So then volume of the air is nothing but what? Pi by 4. Internal diameter, which is 100 mm. First, I will find out it in mm. Okay, 100 mm. Pi by 4 d square into height is 60 mm. Okay, you will get the answer in terms of mm cube. Yes. Yes, Gabriel or Jagan, anyone answer. Only two of you are attending the session in Zoom. Right. Answer. Volume of air in mm cube. Later on, we will convert it into meter cube. Yes, yes, yes. Answer. Take your calcium. Be ready. Okay. Yeah. 0.47. You are saying the answer in terms of meter itself. Gabriel, is it in? You are saying it in terms of meter itself. Yes, sir. Okay, fine. Fine then. Then I will directly write it in terms of meter, 0.47 meter cube. Okay, so volume of 0.47 seems to be very big. Mm. Please cross check it. 0.47. See, 100 means what? 100 means 0.1 meter. 60 means what? It is 0.06. Okay, so I guess 0.47 is bigger value. 0.47 is bigger. You check it, you cross check it and get the answer. Okay, cross check it and get the answer. We will see that at the end. So now what you should do, just take that all the values and substitute it here. You will get buoyancy force. Okay, that's it. You simply substitute everything. You will get buoyancy force. And what about weight? Weight is rho g of that body itself, whatever the body I am having, multiplied by volume of the body. That volume of the body is nothing but volume of the bowl. Okay, so rho g of body. What is rho g of body? See, the density of the fluid we can determine it, and rho g of the body also they have given a specific gravity, which is 6.1. So 6.1 into again 1000 into acceleration due to gravity 9.81 into volume of the bowl, which is given to us 0.9 into 10 to the power of -3. So if I substitute this, I will get my weight. So subtract that weight and buoyancy force, you will get your force which I need to apply in order to maintain the bowl at that position. 4.10 to the 4.71 into 10 to the power of -4. Okay. 4.71 into 10 to the power of -4 meter cube. Good. So we got air's volume and the volume of the bowl. Take them both, substitute here, and you will be getting the buoyancy force, and also you can calculate weight. Subtract them both, you will get the net force. Okay. So fast, do it, and give me the answer. So here the only logic you need to understand is that there was an excess air which is also submerged. Okay, so that is the only logic. Other than that, the problem is nothing, very simple. So I hope you will be able to solve it. If you could give me the answer, just give me the final answer. That will be enough. The final answer, that is the force F. The force F, that final answer. Just give me that so that we can move forward for next question. What happened? Any answers? Okay, I will just give the answer then, because necessarily I don't want to waste the time. As I said already, I want to discuss variety of questions. The final answer will be 154.9. Okay, you practice it after the session. Okay, those who are there in the session, practice it after completion of the session. Okay, answer is 154.9. Yeah, 155, 154.9. It is correct. It's correct, Gabriel. Correct. Okay, see, these are pressure measurement, right? We will do buoyancy questions first. Okay, so this is a buoyancy question. We'll do buoyancy question first, and then we'll come back to pressure measurement. Right? It's again a buoyancy problem only. We'll do all the buoyancy questions first, and then we'll come back to pressure measurement. Try this. So homogeneous timber AB of 0.15 meter by 0.35. So 0.15 meter, they have mentioned it, as you could see, 0.15 meter is nothing but the thickness, okay, thickness. 0.35 in cross section, which means if you see from this direction, okay, if you see from this direction, you'll able to see the cross section, right? That cross section is what they have given to us. Okay, that cross section thickness is 0.15 and width is 0.35. Okay, and length, anyways, which we already know, 8 meter plus 2 meter. That is what the length, which we already know from the diagram, right? Now they are asking what is the tension in the rope. It's very clear. You could see there is a timber rod. Okay, we have a timber rod in which at one end, at end A, we are connecting it to some weight. Okay, some weight. We don't know what is that weight is, but there is some weight. Okay, there is some weight. There is some weight which is placed here, and that weight is connected to A. Okay, and we need to find out what is that? We need to find out what is the tension in that rope. So if I draw the free body diagram, okay, I'm drawing the free body diagram. If I draw the free body diagram for this particular, what is that? For this particular, sorry, yeah, for this particular timber rod, okay. Okay, just cope up with this. Let us, or else I will do one thing. Yes, let us consider this is our timber rod. Okay, this is our timber rod, and what are all the forces this timber rod is going to be subjected to? What are all the actions and what are all the reactions? If you consider action, there is only one action here, that is weight. Okay, that's going to be weight. Of course, it's going to act exactly at the center. Center means this totally 10 meter, right? So exactly it will be acting at 5 meters. So let us consider this is the weight. Okay, this is the weight, and then there is going to be tension right here. Okay, if I cut this rope and if I see, there is going to be a tension. So tension which is going to act down, and in addition to that, it is placed in a water, and some amount of the body was immersed inside the water. So there is going to be a buoyancy force. And where does buoyancy force acts? Buoyancy force acts at the center of the submerged body. Okay, centroid of the submerged body. So we will take it somewhere here. We'll take it somewhere here. That is our buoyancy force. Okay, so we will consider that. Yes, this is the free surface. Okay, this is the free surface. Okay, now, so these are the three different forces which we have. Okay, three different forces which we have. We will do one more thing. We will take this angle to be some alpha. Okay, so this angle was some alpha. Okay, if this is alpha, then this is also alpha, right? If this is alpha, opposite angle. If this is alpha, this is also alpha. You could see in this diagram. This is alpha, this is also alpha. Okay, right. Let us come back. So now what are all the different equations I can apply? See, for an equilibrium, there are three actually, but here there is no forces acting in horizontal direction. So one is summation of force in y direction should be 0. Another one is summation of moment about the point A should be 0. So these are the two equations which we have. Not only about point A, you can take about any point, but I'm going to take about point A or any other point so that it will be convenient for me. Okay, it is your wish. You can take any point as you wish. But you could see they have given it as water. Okay, no problem. And other than that, there is no other data which has been given to us. Okay, no issues. We will start solving the question so that we can understand. We can proceed. We'll proceed and we will get the answer right. Okay, and also. Just a moment. They have not mentioned about what is the density of water, right? Density of water generally will be given to, that is generally we used to take it as 1000. Okay, do one thing, like I will include one more statement in this question. Okay, consider gamma to be specific weight. Okay, specific weight of what is that? Specific weight of this this timber rod. Okay, timber rod. Right, timber rod. Let it be gamma to be gamma as a specific, or gamma or omega, whatever you want to take. Okay, so first, if I take this equation, that is summation of Fy is equal to 0, what are all the forces which is acting down? One force which is T, which is acting down, and Fb acting up, and W acting down. So all the forces which is acting down will be equal to some of the forces which is acting up. So I can simply make it like T plus W is equal to FB. Okay, T plus W is equal to FB. One more moment about point A is equal to 0. This is what we need to determine, right? So this is point A. Now let me just draw a dotted line here. Okay. Now see, now we know that this total distance, okay, this total distance was 8 meter. This total distance was 8 meter. Center of buoyancy will be acting at the center. That means it will be like this side, it will be 4 meter. This side will be 4 meter. And weight, if you consider from overall, weight will be acting at the center for the centroid of the complete body. So which means 5 meter, because total is 10, right? So weight will be acting at 5 meter from this end, okay, from this end. And center of buoyancy will be acting 4 meter from this end and 4 meter from this end, because center of buoyancy will be at the centroid of the immersed body. Okay, right. Now we need to find out moment about point A. So what I should do? I will do one more thing also. I will name it. Let me take this as C. Let me take this as D. Let me take this as E. Let me take this as F. Now, if I find out moment about point A, this is going to be FB into this distance, right? FB into FE. Okay, FB into FE. And how it is acting? It is acting in anticlockwise direction. Let me take anticlockwise to be positive. Okay, W into FD, and W into FD, it was acting in clockwise direction. So W into FD, okay, which is acting in clockwise direction. That's why minus, which is equal to 0. So this is from summation of MA is equal to 0. So now I can make FB into FE, which is equal to W into FD. Okay, what is FE, or what is FE, or what is first of all, what is this FD? Okay, what is this FD? This distance. FD means this distance. FE in the sense this distance, right? So how can I determine FE and FD? Just take this triangle, okay, from this triangle ACF, okay, from the triangle ACF, I can write CF is equal to what? If this is alpha, okay, if this is alpha, then CF will be AC cos alpha, right? AC cos alpha. Okay, and what will be my CD? CD will be, if I take this is to be center O, then it is OC cos alpha. Am I right? Simply I'm finding out, I'm resolving this line horizontally. Okay, so AC cos alpha will be CF and OC cos alpha will be CD. Okay, next, if I subtract this CF and CD, I will get FD. So that is what I want, right? That is what I want. So simply I need to subtract this two. Okay, what about EC? Okay, what about EC? EC will be, if I take this distance to be, this is O, right? So I will take this is O dash. Okay, let it be O dash. Then O dash C into cos alpha. I hope you are getting my point. What I'm doing, I'm resolving this distance. Okay, I'm resolving this distance along horizontally. Okay, and now we know what is AC. What is AC? AC is this total distance, which is given as 8 meters. And OC is this distance. OC, yeah, where it is, OC. Yeah, OC is this distance. OC is this distance. We know total is 8 and this was 4. Okay, total is 8. If this is my center, this was 4. Okay, this complete distance was 4. Okay, and this point is present at a distance 5 meter from this end. Okay, from this end, this point is present at a distance 5 meters. So what will be this distance? That's what I need to find out. The distance, I need to find out what is OC. Okay, we also know one more thing. We know that this is 2 meter, right? We know this is 2 meter. So this is 5 meter, this is 2 meter, means this is simply 3 meters. So OC is 3 meters. So OC is 3 meters. And what is O dash C? O dash is here, C is here. Okay, so this is 3 meter. Okay, we already know that. We already know that is 4 meter, right? So O dash C is 4 meter. I hope there won't be any confusion here. Right, now just substitute it to FB into FE, which is nothing but CF minus or CF minus CD. Yeah, CF minus CD. This is CF, this is CD. So if I subtract them, 8 minus 3, which is 5, right? So or else if you want to write, you write it. I'll directly write it 5 cos alpha, which is equal to W into what is FD? FD is this distance. FD is this distance. That distance is nothing but total distance, that is CF minus I'm sorry, FE, I need to first find out. Okay, okay. Just a moment, just a moment. So FE is this distance, right? FE is this distance. FE will be what? Total distance, that is FC, minus this distance. So total distance is FC, and if I subtract CE, okay, if I subtract CE, what is my CE? You already know, 4 cos alpha. So 8 minus 4, that's going to be 4 again, 4 cos alpha. W into FD. What is FD? FD is just this. Okay, FD is just this. That is nothing but the total distance, which is 8 cos alpha, minus this distance, that is 3. Okay, so that's going to be 5 cos alpha. So cos alpha I can cancel. So finally, I'm getting FB into 4 is equal to W into 5. And this is my one equation. Now you could see we have two equations, right? This is one equation. This is one equation. And what are all the unknowns we have in the question? We don't know tension. Okay. The problem with the question is we have to find out the tension. But for finding out the tension, we need buoyancy force, and also we need weight. But for finding out weight, we need the specific weight of the timber rod, but I don't know the specific weight of the timber rod. Now I have this equation. From which I can find out the specific weight of the timber rod. First of all, what is my buoyancy force? Rho G of the fluid into volume submerged, right? Which is equal to density of the fluid is nothing but water density into G. That is acceleration due to gravity, no issues. And what is my submerged body? Submerged body is volume. See how much body is submerged. This is the amount which is submerged. This is the amount which is submerged. Length is 8 meter, and cross section area I already know 0.35 into 0.5, which is given to us in the question. Okay, so this is 8 into 0.35 into 0.15. So this will give me density of water. You take it as 1000. Okay, so this will give me buoyancy force. And now from this, I don't need to find out the gamma. Okay, from this, I can directly find out W. What is W? 4 by 5 into buoyancy force. Okay, 4 by 5 into buoyancy force. So directly find out W. Take it and substitute here, you will get tension. Okay, what is my tension? Buoyancy force minus W. Okay, so or else you directly substitute here also. That is also fine. 4 by 5 of buoyancy force. That is 1 by 5 of buoyancy force. Whatever the value you are calculating from this, take it, substitute it here, you will get the tension. Okay. Any doubts? Like why I'm using this moment equation to solve? Okay, I'm using the moment equation in order to find out W, because I don't know W directly. If suppose they have given you the specific weight of the timber rod, or if they have given you the density of the timber rod, then I would have solved this question without doing all this moment equilibrium, directly with the force equilibrium. Okay, any doubts? Any doubts? If not, like finally get the answer. No, sir. Okay, just get the final answer. Buoyancy force. What is my buoyancy force? What is our buoyancy force? I will give you the final answer. Okay, so buoyancy force, you calculate it and give me the answer at the end. Okay, so buoyancy force is 824. That is the final answer. Final answer is 824 Newton. Okay, so 4120 by 5. Okay, 4120 by 5. That will give me the tension. Okay. Right. Proceeding to next question. Next, we will discuss one more buoyancy question is there. Yeah. Read this question. It's a conceptual question only. Read it and try answering it. Read it and try answering it. Option A. Any others with any other answers? Any others means what? The remaining whoever was there in the live. Yeah. Any other answers? H increases. Okay. Right, right. Okay. H increases. Okay. Right. Lambda decreases. So which means almost everyone is going with option A, right? We will do an analysis. We'll do one small analysis, and then we will start. We'll solve this. Okay. So we will do one thing. Let the coin's density be rho c, and let what is this wooden, right? Wooden plate. Let wooden plate's density be rho w, or else okay rho w. Let the fluid density be rho f. Okay. So this is the initial condition. This is the initial condition before dropping the coin inside. And this lambda is this distance. Okay, they have given as the distance what this distance what is that the wooden block was submerged inside. This is the initial condition. Now the second condition is I'm just dropping this. Okay, I'm just dropping the coin inside. I'm just dropping the coin inside. So now what will happen to what will happen to the submerged volume? Let me take it as lambda dash. And also they are asking what will happen to this h dash. Okay. So how these things are going to be different. See, in fact, I have solved one question related to this in our course. Okay, I have solved it, but it will look different in course, and like this question will be different. I mean, if you just read this question in general, you won't able to relate this question with that question which we done in course. Why it is, I will explain to you. Okay, so let us first take the first condition. There is what is that? There is a block and coin. Both of them are floating. Initially, both of them are floating. So in the first condition, since it is floating, we can directly say the total weight of the body should be equal to buoyancy force. That is the condition of what is that? That is the condition of floating body, right? So weight of the body will be equal to mass of the body, which is multiplied by g into buoyancy force is nothing but mass of the fluid. I should not consider the or else I will directly write down why I need to confuse it. I will write it like rho f g into vfd. Okay, the how much volume which has been displaced. Okay, so we know this, and this is for the first condition. Okay, and what is my mass of the body? See, if you consider mass of the body, here in the first condition, both coin and wooden block was floating. Okay, so mass of the body will be density of what is that? Or else I will do one thing instead of considering mass. And so that is, instead of writing in terms of density, mass of the body, I will write it as mass of the wooden block plus mass of the coin. Okay, mass of the wooden block plus mass of the coin into g, which is equal to density of fluid into g into v of d. Let me keep this as my first equation. Now coming to second condition. In second condition, we have two things. Okay, so first one is the wooden block was floating, right? The wooden block is still floating. Since the wooden block is floating, we can use the what is that? We can use the condition. We can use the floating condition. So weight of the wooden block will be equal to buoyancy force now. Okay, buoyancy force, I will consider FB dash. Okay, total buoyancy force will be FB, that is like, or else I will write like this. Totally, if you consider the second case, we will be having two buoyancy force. One is FB dash, which is the buoyancy force acting here. Okay, another one is buoyancy force acting on the coin, which I will take it as FB double dash. Okay, so two buoyancy forces will be there. Okay, two buoyancy forces will be there when it comes to second case. One is the buoyancy force acting on the submerged body, completely submerged body. Another one is buoyancy force which is acting on the floating body. And we can equate the weight of the wooden block, which is floating body, to the buoyancy force because it is still floating. Okay. So now in this case, weight of the wooden block, I can write it as mass of the wooden block into g, which is equal to buoyancy force. Buoyancy force now. What is my buoyancy force? The present buoyancy force, as usual only, that is rho f g, but volume of the fluid displaced in this case, which I will take it as vfd dash. okay, which I will take it as VFD dash. Okay. Right. So this is what this I will consider to be second equation. And now what about the third equation? What if you consider the coin? If you consider the coin is completely submerged, right? So weight of the coin, and if I want to find out the buoyancy force which is acting on the coin, these two will not be same because it is submerged. So weight of the coin is greater than that of the buoyancy force which is acting on the coin. So what is weight of the coin? You consider weight of the coin, mass of the coin into G, which will be greater than that of buoyancy force which is acting in this case, which I will take it as rho F G VF D double dash. Okay, VFD double dash. I will take this as 3. Okay, I'll take this as 3. Right. And now add 2 and 3. If I add 2 and 3, what will happen? If I add 2 and 3, 2 plus 3. See, left hand side I have MWG, right hand side I have MCG. Here equal to, here greater than. So if I add this left hand side, okay, if I add MWG plus MCG, then it has to be greater only because this is equal to this is greater. Okay, this is equal to this is greater. So if I add them, it has to be greater only. I will take rho FG into VFD dash plus VFD double dash. Okay, and what is this if I add them combinedly? I can write like this, which is greater than rho Fg into what is this? Vf dash plus Vf double dash. This is the total volume of fluid which is displaced in second case. Okay. And what is this Mw plus Mc into G? You already got it. Mw plus Mc into G is nothing but rho Fg into Vft. That is for the first case. Okay, for the first case. So now take it, substitute it. So rho Fg VFD for the first case greater than rho Fg VFD for the second case. So cancel these two. So finally, I will end up with volume of fluid displaced in the first case is greater than volume of fluid displaced in the second case. Right. So this is our final, like I have done one small mathematical analysis and this is what I got. Okay. So with this, what I can conclude, that is my question. See, volume of fluid displaced means what? Volume of fluid displaced means what? The volume which is getting, suppose if I drop something, how much volume it is displacing, how much volume it is rising simply. Okay, how much volume it is rising. It's very clear. In the first case, volume of the fluid displaced is more, and in the second case, it is less. And now give the conclusion for H. Still everyone going with H increases. Still everyone going with H increases, H decreases. Exactly, Diwakar. So all three of you, whatever you said, H increases is not correct. Okay, because the second case volume is basically, that is the volume which is getting displaced is actually lesser than that of the first case volume. So second case, the volume which is displacing is lesser than that of the first case volume. So obviously this H value, okay, H dash value will be less than that of H value. Okay, so H is decreasing. And lambda, see, this is very simple one. Okay, we don't need to do this much analysis to understand it. And whatever you guys said, that is true. If I remove this coin, okay, then obviously this, what is that? The weight, okay, the wooden block is going to move a little bit higher. Okay, obviously it's going to move a little bit higher if I remove this coin. So this lambda dash is surely going to be less than that of lambda. There is no doubt about it. There is no confusion about it. If I take this coin, there is going to be little movement upward. Okay, since if this block moves little bit upward, then lambda dash is surely going to be less than that of lambda. So lambda decreases, which means lambda dash is less than lambda. Okay, so our answer, both lambda and H decreases. Yes, option D. So others, I guess Diwakar understood. What about Gabriel and Jagan? Fine, or any doubts? Yes, sir, understood. Okay, right. Super then. It's a very good question. See, try recollecting it. What is what is that one question which we did in our course? We have did one question, similar question in course, or not exactly a question, but similar. Yeah, similar to that cube, and also we did one plastic board question. Yes. So it's a similar one. Okay, we'll move for the. So for today we have that much buoyancy only. We will come back to buoyancy later. Okay. Yeah, try this. This is pressure measurement. Yes, shall we solve? I hope we can solve the question. Right. A 25 mm diameter glass tube contains water column up to 50 meters. So they said that the water column is 50 mm. Okay. So this total water column is 50 mm. Assume applied pressure, and also they said that the diameter of the glass tube. Okay, diameter of the glass tube is also given to us. And take theta to be 0 degree. Just a second. Theta 0 degree, column height is. Okay. So theta to be 0 degree, column theta to be 0 degree, and density of the water is given, and column height is the sum of capillary rise and the pressure difference. Okay. Right. Listen. They said that there was what is that? The fluid, that is the water, is rising in the capillary tube. In that capillary tube, whatever the fluid which is present, that has two height. We can say that we can divide it into two. Okay, one rise in the height is due to capillary action. The other one is due to pressure, because we know that, right? Like you consider this fluid, the fluid which is present here is having some pressure. Due to that pressure, the fluid will rise. We know that very well. That is what we are studying in pressure measurement. Okay, so due to the pressure at this point, the fluid is going to rise. But here in this question, not only due to that pressure, in addition to pressure, we have capillary rise also. So total height, just consider the example of piezometer. Okay, in piezometer, what will happen? If the pipe is there, if I connect a piezometer to it, there will be rise. But that rise is entirely due to pressure. But here the rise, whatever the rise in the height, delta H, is not only due to pressure but also due to capillarity. Okay, that is what they're given. So now the question, what are the question? They are asking different things like the pressure difference height. Like they are asking about this pressure difference height, delta HP. And when initially they given the diameter to be 2.5 mm, if I change the diameter to 1 mm, what will happen to my total height? That is what the question is. Okay, so first we will find out, that is, it's an MSQ question. Okay, it's an MSQ question, multiple choice question. So first what we will do, we will find out the pressure difference height. That is, we will find out this delta HP. How can I do? So we know the total height, which is 50 mm. And if I able to find out this capillary height, okay, which we know the formula, right? What is that? 4 sigma cos theta by rho GD. Okay, so just confirm with the formula. I guess it is correct. My formula is correct. So this will give me capillary rise. Okay, So 4 sigma, which is given to us, you could see that it is given to us 4 into 72.8 into 10 power minus 3 cos 0. Okay, because the angle is 0 degree. So cos 0 by rho g, density is 999, and acceleration due to gravity 9.81, and diameter, initially diameter they asked us to take 2.5. Okay, 2.5 into 10 power minus 3, 2.5 mm, so 10 power minus 3. This will give me height of capillarity. That is, how much is the rise, how much is the liquid rise has happened due to capillarity, which means this rise. Okay, I'm talking about this rise. Okay, I'm talking about this rise. How much rise has happened due to capillary effect? Answer, 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 fast. Just solve it and give me the answer. Little bit faster, we can finish this question quicker. Yes. 0.0118. Any others could confirm that? 0.0118. Or else I will verify. 0.0118. Yeah, correct. 0.0118. Fine then. 0.0118 meters, which is nothing but 11 point. I'm sorry. It's nothing but 11.8 mm, right? 11.8 mm. Now I got this height, delta hc. Simply I can find out delta hp. Okay. So delta hp will be what? Delta hp will be equal to total height, which is 50 mm, right? 50 mm, I'm sorry. So total height is 50 mm minus delta hc, if I bring it there, minus of 11.8, which is going to be 38.2 mm. So when the diameter is 2.5 mm, the height due to pressure was 38.2 mm. 38.2 mm, yes, 38.2 mm, which is option A. But as I said already, it is an MSQ question, so there is going to be more than one correct answer. Option B is obviously not correct. We know that because we already got option A correct. So out of this C and D, there should be one more correct answer. Now what I'm doing, I'm changing the diameter. Okay, the diameter is changed to 1 mm. They are asking what is the total height, which means they are asking delta H. See, now you might have a doubt, sir, why? Which means why there is going to be change in the total height? There will be change in the total height. Any answers why? Why total height will get changed? Will there be any change in my delta HP? See, initially total height was 50 mm, but now there will be some change in the total height. But why it is happening? Yeah, diameter decreases, correct. Diameter decreases means what will happen? H is inversely proportional to D. Which H? Which H? That's what I want. Which H? Which H is inversely proportional to diameter? See, not both the H is inversely proportional to diameter. This H, that is delta HP, depends only on the pressure here. It depends only on the pressure in this fluid which is flowing. It doesn't depend on the diameter at all. Okay, it doesn't depend on the, yes, correct. It doesn't depend on the diameter at all. The rise, the in this rise, that is in the total height, this delta hp depends only on the pressure. This delta hc is dependent on the capillarity. Okay, and capillary rise depends on the diameter. Capillary rise depends on the diameter. So in our first case also, our delta hp will be 38.2, and second case also it is going to be 38.2. Okay, but in the second case, my delta HC will change. Okay, what is going to be that? 4 times of sigma again, cos theta by rho g d2 we can take. Okay, d2 is 1 mm. So if I substitute it, 4 times of sigma, which is 72.8 into 10 power minus 3. Cos theta is 1 anyways. Cos 0 is 1. Density 999 into 9.81 into diameter 1 mm, which is 10 to the power of minus 3. Answer for this. Answer for this. This is our delta H C double dash. I can take 0.029. Okay. 0.029 meters, which is 29 mm. Okay. Right. Now, what will be my delta H dash or delta H double dash, which is nothing but delta HP will not change. Okay. There is no change in delta HP. The only change happens with delta HC. Okay. So delta HP, no change at all. So 38.2. Delta HC is changing to 29. I'm sorry. Delta HC is changing to 29. So if I add them both, 29 plus 38.2, how much it is? 67.2, right? 67.2 mm. Yeah, 67.9. 2, right? 67.2. Okay, you might have taken with some extra decimal places. No problem. You might have taken with some extra decimal places. No problem. So 67.2, which is, yeah, which is option C. Okay, 67.2, which is option C. So option D is wrong. So for this question, the correct answer is A and C. Okay. Okay, 67.3. Fine, fine, no problem. So I hope it is clear. There won't be a problem in this question. It is also a good question, basic question only, but it's a good question because we would have never seen this type of question in any of the exams where they are mixing the pressure measurement concept with the capillarity concept. We are mixing the pressure measurement concept with the capillarity concept, and it's a good question. It's an easy question, but it's a good question, and that too, it is an MSQ question. Right. One more question. This is also from pressure measurement. Try solving this. Right. Shall we proceed? Shall we proceed for the question? This will be the last question of today's session. Right. It's a little bit bigger question, but we can solve it. Not that much. A 15.24 centimeter diameter piston is located within a cylinder that is connected to 1.3 centimeter diameter inclined tube manometer. So this is having an inclined manometer, which is having a diameter of 1.3, and piston diameter is given as 15.24. Okay, let it be. The fluid in the cylinder and the manometer oil, okay, that is this completely, okay, this completely is a single fluid only, is an oil. Okay, the fluid in the cylinder and also which is in the manometer is simply an oil, and they given the oil specific weight is 9.3. Okay, a weight W is placed on the top of the cylinder so that the fluid level in the manometer tube rises from 0.1 to 0.2. This is our condition in the question. Okay, initially there is no weight, but now I'm adding a weight. Now I'm adding a weight, and because of this weight, the oil level is getting increased by how much? 15 centimeter. So there is an excess oil which is getting filled here. Okay. Now what I need to find out, I need to find out what is the weight which I placed. Okay, I need to find out this W value. Okay, it's a good question, right? So first of all, we will take the first condition where weight is not placed. Okay, I'm not placing the weight. I'm not placing the weight. Okay, only piston is there. Okay, only piston is there. So if you consider the piston alone, okay, if you consider the piston alone, there is going to be atmospheric pressure, of course. There's going to be atmospheric pressure, and there is going to be weight of the piston. Okay, these two combinedly is going to generate the pressure here, right? Combinedly, they are going to generate the pressure here. So that is what that will be the pressure at this point. I will take it as PP. Okay, so pressure here, okay, pressure at the base of the piston for the first case, when the weight is not added. Okay, PP will be not directly, we won't say it as a PP. We will consider the cross section area, right? PATM into A will give me the force which is acting on the top side. PP into A will give me the force which is acting on the bottom side. So if I focus on the summation of Fy equal to 0, that is if I focus on the condition, what is that? Summation of Fy is equal to 0. So PPA, which is acting up, minus PATMA, which is acting down, minus WP will be equal to 0. So PP, if I want to calculate, that is going to be PATM plus WP by A. Okay, this is our first case. So this is what PP. PP is nothing but the pressure at this place. That is simply atmospheric pressure plus pressure due to weight of the piston alone. WP is weight of the piston alone. Okay. And now for at this condition, okay, at this condition, we know that at this point, there is, don't consider the weight. Okay, don't consider the weight initially. For the first case, don't consider the weight. Pressure at this point is PP. Now apply the simple what is that? What that is our logic. What is that? Oh, draw the datum line. Okay, just draw the datum line. Just draw the datum line. Just draw the datum line. Sorry, just draw the datum line. If I draw the datum line, okay, pressure at this point is PP. Left limb pressure is PP, which is equal to, I don't know what is this height, so we will take that height to be some H1. Okay, some H1, and this angle is given as 30 degree, right? So what is going to be this? This is H1 sine 30. Okay, so H1 sine 30. And density of the oil, I will just take it as rho G, and height is H1 sine 30. Okay, density of the oil not given, but they given the specific weight. Okay, specific weight is given. So this is what we got. We will keep this as our first equation. And now go for the second condition. Second condition is something like, here we have a piston and we have a weight. We have piston and we have weight. And now at the bottom, that is now second case, we have weight also. Okay, now second case, we have weight also. And now the pressure here surely would have increased. Okay, so let us take that as PP dash. And how much will be that pressure? The pressure which is acting here. I'll take it as PP dash into A. That is the force which is due to the pressure. If you consider this pressure, there are going to be different things. One is atmosphere. Okay, PATM into A. And this weight of that, the new weight of the block, and also weight of the piston. So now if you consider the equilibrium, equation, P dash A minus WP minus W minus PATM. So the new pressure PP dash, okay, that is due to weight of the piston, weight of the block, and also the atmospheric pressure. Just rearrange it. I can write it as PP dash is equal to, bring all the terms to the side. There is W plus WP plus PATMA, the whole divided by area. So that will become W by A plus PATM plus WP by A. And what is this what is this PATM plus WP by A, which we already got, which is PP. That is the initial pressure. So PP dash is equal to W by A plus PP. Okay, and now see, we know, okay, let it be, we know pp dash, right? From this equation I can replace pp dash as rho g h1 sine 30 in this equation. And area we can we know the diameter 15.24 centimeter. So area of that piston, okay, area of the piston I have taken it as a only. Okay, so I will simply fix it with a. Okay, a, which is area of piston, which is how much? 5 by 4 into diameter is 15.24, so 15.24 into 10 power minus 2 whole square. So that is area of the piston. Okay, that is area of the piston. So now I know area of the piston. Okay, I know area of the piston and I know an equation for pp. Okay, I know an equation for pp. I want to find out w. Okay, now what I can do? Same, go and put the datum line. So now if I put the datum line, now if I put the datum line, this is going to be the datum line, no doubt. But the pressure at this point will be pp dash now. Okay, and height of the fluid has raised. How much it has raised? From h1 it has raised to h1 plus 15 centimeter. Okay, 15 centimeter, that is 0.15. Okay, 0.15 meters. And now I will apply that for the second condition. Okay, for the second case, if I apply, pressure at this point is pp dash, which is equal to pressure at this point, which, like, pressure due to this, that is going to be what is that? That is going to be rho g h1, rho g into h1 sine 30. Sorry, or I'll directly I will write down rho g into h1 plus 0.15. Okay, 0.15 sine 30. Okay, rho g into h1 plus 0.15 sine 30. Any doubts here? How I'm writing it? Just simply I'm making that what is that? I'm equating the manometer. Okay, and now pp dash, we know pp dash is what? W by a plus pp, right? So w by a plus pp, which is equal to rho g into h1 plus 0.15 into sine 30 into Newton. Sorry, into n. Second, you are saying the final answer, or in second case h1 changes? Yes, in second case. See, no. Uh, like you are saying that that distance h1 will vary, right? That is what you are saying. That is, initially h1 will be different. Later on, h1 will be different. Okay, so due to the drop, due to that drop in this, that drop in this oil. Yeah. I understood your doubt. Okay, I will clarify it. See, go through the question again. The manometer tube rises from point 1 to point 2. The weight placed on the piston is dash. Okay, they have given it. I'm sorry. Assume the change in the position of the piston is negligible. Okay. They have given it. They have given as that you assume the change in the position of the piston to be negligible. Just once again. Yeah, that is what Jagan, I hope you got it. Like they are asking us to neglect the change in the position of the piston. Okay, since they are asking us to neglect the change in the position of the piston, we are not going to consider that change in this H also. The position remains almost same. That's what we are considering. The position of the piston is not changing, so this H1 is also not going to change. Okay, right. Let me just proceed. W, wait. Okay, weight is what I need to find out. Area I know from this. From this I can substitute the area plus PP. What is my PP? Yeah, PP is here. PP is rho G into H1 sine 30. And the right hand side I can write like this, rho G into H1 sine 30 plus rho G into 0.15 sine 30. Okay, so I can write like this. I can cancel this too. Take this area that side, you will get the W. Okay, any doubts? You can calculate W from this equation. There won't be a problem. Any doubts? So the final answer, you will get it as 12.72 Newton. Okay, the final answer 12.72 Newton.